Hello, welcome back to a new video in the Java for Beginners series. In this video, we're going to look at the var keyword and casting. So the var keyword is a fairly new feature in Java. It simplifies declaring variables using type inference. And we're going to look at casting, the two types of casting, the implicit and explicit. So if this sounds like fun, keep watching. And now let's talk about the var keyword. We're looking at some variables over here. So we've got number, price, letter, is Java fun, int, double, char, boolean. And we're just printing them. So let's try that out for now. Nothing we didn't expect. Now I'm going to go and replace each one of those with the keyword var. I'm going to hit run. Nothing changed. So what's happening here is this value is an integer. It's not a long, it's not a short, it's not a byte. It's an integer by default, because by default, any literal number is an integer, a whole number. So the compiler is like, oh, I've got an integer here that is being stored in this variable. So this must be an integer. Same goes for a double, not a float. By default, if you have a floating point and a number and it doesn't have an f at the end of that, then it's considered to be a double. And so the compiler is like, okay, so this is a double, I guess. And you're assigning a character here, so I guess this is a character. You're assigning a boolean here, so I guess this is a boolean. I want you to pay attention to a couple of things here. Do you remember how we had the ability to say just declare num as a variable and then say num equals 1, right? Do you remember that? We could do this with any data type that is primitive. However, you cannot do that with a var. So a var is a compiler trick. So it needs to know exactly at this line of code what is going to be stored in this variable, so that, do you remember how like primitive data types differ in sizes? So what size is it going to allocate for a number in memory? Is it going to allocate 8 bits or 16 bits or 32 bits or 64 bits? It doesn't know. So you always have to do the allocation or the declaration and the assignment of a value in the same line so that it knows how much memory it should allocate for number. And it knows that by looking at the value that you're assigning to that variable. Now, the second thing you want to know about is, now this is presumed to be an integer. So if I took number is a variable, so I can reassign the value for it again and again and again. And so what if I tried to give it the value of false? I see the compiler is complaining because the required type is integer and I'm providing a boolean. And if I try to hit run, it's not going to work because it's telling me incompatible types. Let me show you something that you might not immediately expect it to work, but what if I try to assign a character? It seems to be working fine. Why is that? Let me try to run that, and actually I'm gonna get rid of the print statements and just cleaned up the code. And let me hit run and see what's going to be printed. I got 97 printed for assigning A. Why do you think that is? Remember when we talked about Unicode letters and we came across the letter A? And the decimal representation for the Unicode for the letter A is 97. So what actually happens here is this is being implicitly casted. So the two types of casting are implicit and explicit. So for implicit casting, you actually don't have to do anything extra for the compiler to perform the casting. Where for the explicit casting, you have to, like, do you remember between the brackets, the parentheses, we would say long or integer, etc., whichever type you're trying to cast to, and that is the explicit casting. So I'm going to hide my picture for a second here. Say that you want to cast from character to integer, just like we did earlier. Well, character is only 16 bits, whereas integer is 32 bits. So that is a widening casting, as in it's implicit. However, if you go back to the code, I can simply do this. I can turn it into an explicit casting. And you see what IntelliJ is doing. Casting A to integer is redundant. So it is telling me, yeah, cool, I see what you're doing, but you don't really need to do that. going back to our slide. Let me hide my picture again. Cool. If you're casting from, say, long to integer, then what you're doing is narrowing conversion, which is not going to happen automatically. So you need to be explicit about it. You need to tell the compiler, I'm moving from a bigger to a smaller size. And remember what we said, you want to be careful performing these types of casting because the results can be sometimes unpredictable because you're going from a bigger container to a smaller container. So sometimes when you're working with a bigger container, there are bits that are important that are being discarded when you're moving to the smaller container. So the number actually changes. Sometimes you can go from a positive number to a negative number. So you really advise not to do it unless you know what you're doing. Let me show you another example. So our new example is defining a long y equals this huge number, and then x being assigned to the casted value of y to integer. And then I'm going to print the two values. So let's have a look and see what's going to be printed. See, this number was printed just the way it was, but this number has been basically trimmed. So some of the bits that were very important in that number were discarded. And so we ended up with this negative number. Now the number being negative has to do with the way these numbers are stored in memory. So that's a topic for another day. I want to show you what happens if we just store 100, which integer should be reasonably okay to store 100. If we hit run, we get 100 printed twice. So again, only if you know what you're doing. If you get rid of that explicit conversion, you get that the required type is integer and the provided type is long, and it's suggesting that you should perform a casting operation. So the IDE is helping you to get rid of that error. Now, going back to our original example, this guy. So I'm gonna, print the number again, and I get 97. So what happened was that this is a smaller type that got converted or widened into a larger type that is inferred from this number literal, which is integer. So if I define, I don't know, a short, so let me define a short x equals 12, and then I take that short value and I assign it to number and hit run. I'm not going to need any conversion. If I change that short to long, then I'm going to need to perform an explicit conversion. Why? Again, because you're trying to assign long into an integer. So here's what I'm trying to say. Once you've defined your var and assigned a value to it, then the var will be switched and replaced by the actual type that is being created. So all the rules that would have applied if I just had integer here would still apply for var. So if you need to do conversion, you do conversion. If you're trying to assign a type that is flat out not compatible, like for instance a boolean type, there is no way to convert that. Like you really can't perform a casting here. Like I'll try to cast to integer, it's not going to work. So I hope this helps you get familiarized and understand how var works. Note that there is more to var, but for the time being, because of our limited knowledge at this point in the course, we're just going to stick to this much of information about var. Thank you for watching the video. I hope you found it useful. And if you have, thumbs up and subscribe. And I will see you in the next one. Bye-bye.